And on your exam for this type of problem, they will give you the curve. So in the 3 examples that are on your practice test, you're given the graph ahead of time. But just so we can practice graphing, this first curve has a root at 0 and 3. But it's an upward facing parabola, so it looks like this guy. And then this second curve has roots at 1 and 6. And so we are trying to find the area between them, which looks like it's going to be right there. Okay? So we need to find those 2 points so we can find the bounds for our integral, and then we're going to take the difference between them. Once we have the bounds, we can just plug in a number between the 2 bounds to figure out which graph is on top. I am pretty sure it's going to be the second graph, but we'll check just to make sure. So we'll start by setting these 2 graphs equal to each other. So 2x squared minus 6x equals x squared minus 7x plus 6. So I'm going to get everything on one side. So 2x squared minus x squared is x squared. Plus x minus 6 equals 0. So this will factor into x plus 3 times x minus 2 equals 0. So x equals negative 3. Or x equals 2. So this point is going to have x value negative 3. And this point will have x value positive 2. And we don't need to know the y values for those 2 points. We could find them by plugging into either equation. But we don't need them because the integration bounds are just going to be the x values. And then the easiest thing to do to figure out which one is on top, 0 is between negative 3 and 2. So let's just plug in 0 into our 2 equations. And we can see that the green curve is going to be the one on top because when you plug in 0 into the green curve, you get 6. And when you plug in 0 into the purple curve, you get 0. Does that make sense? So the green curve is on top. So this is going to be the integral from negative 3 to 2 of the green curve first. So x squared minus 7x plus 6. And then minus the lower curve, 2x squared minus 6x dx. Is that okay, guys? All right. So at this point, we can simplify this before we integrate just to make our lives a little bit easier. So it's going to be negative x squared minus x plus 6. And so when we take the antiderivative, we're invoking that fundamental theorem of calculus here. We get negative reverse power rule says we bump the exponent up by 1. So that's x cubed, and then we divide by said exponent. So there we go. Minus x, we'll bump that up by 1. Then divide by that exponent, and then plus 6x. And now this is a definite integral. I put the integrand here even though I integrated, and I apologize for that. This is the integral from -3 to 2. So that integrand shouldn't have been there. Does this make sense to everybody? Did I do it right? Are we good? Okay, and now I plug in I plug in 2 first, the upper bound. And then -3. Be sure that this whole thing is in parentheses. Okay. So I have very little space, so I guess I'll just copy and paste this and finish evaluating it on the next slide. So -8/3 minus 4/2, so 2 plus 12 minus, I don't know, 9 plus 9/2 minus, and then plus 18. So this is 9/2 plus 9. 27/2. And I don't think you need to go any further than there, regardless of what the directions say. I'm going to double check and see how far they want you to go. But this is certainly far enough. Yes. Shouldn't what?
9/2 be negative.
So we have a -3 and it's squared, right? So that makes it positive. But we have a minus out front from there, so that makes it negative. And then a minus even further out front. Yeah, I hope that you don't have to take it this far because scions are my arch nemesis. I'm not a fan. Right. So number 4 on the practice final, I am going to come back to when I come up with another function that has nice numbers. I was able to come up with 3 for the practice test, and you guys really have no idea how hard it is.